going to talk about a couple of projects, the Zero Power Reactor and the Imagine project. I wonder if you'd mind explaining how these two fit together in your mind, because some people might see them as two separate things.
But they fit together. The Zero Power Reactor project is more or less the stepping stone to get Imagine going. So it's the pre-project for the first step, let's call it like this, that coincides with the budget we have.
Okay. And then how does that follow on to Imagine?
So in the real world, when we have the right investment, you would go for the Zero Power Reactor experiment, which is then a reactor experiment, not to mix up with a research reactor. So it's an experiment dedicated for the reactor where we try to understand and to measure what responses of the reactor. Then this would lead into a small-scale demonstrator, which is maybe where you, the first time, get the feeling of all the systems together, of power production, of cooling, of radiation damage, of burnup.
So why is it that we need a zero power reactor at all? Some people would claim that we could build these reactors without even bothering with these sort of fundamental experiments. What's your real reason for justifying such a project at this stage?
It's a learning project for everybody of us. We want to go into a new technology. So it's not only for the designers, it's for the people who are engaged with construction, with regulation, all of them. It's a new technology. So, and we can't go along the standard regulation of a light water reactor, since there everything is built on that present experience, which we don't have. That is part number one. Part number two is we cannot rely only on modeling and simulation, since the simulations are always only as good as the validation base. And when we don't have the validation base, when we don't have the real measured values, the uncertainty of our modeling and simulation will be rather high. And at the end, we need to know, for example, how much material do we need to get critical?
Sure. And what does zero power actually mean? I'm sure there might be some people listening to this that thinking that a reactor that doesn't produce any power is not very much use to anybody. So what do we actually mean by zero power for someone who isn't skilled at reactor physics?
Let's put it like this. Maybe zero power is a bit misleading. That's right. A zero power reactor experiment means you don't produce so much power that you need heat extraction systems. So it's not that you don't produce power, but you don't need to extract heat. So that means you're definitely in maximum in the dimension of kilowatts, which then slowly will heat up your system, but you never want to have a heat extraction system, and you don't want to produce real power in a larger extent, since you don't want to.
How did you put together such a motivated team?
That is a good question. How do you get a motivated team? Find some interested young people who have the feeling that you do something useful for the world. I think these are the key points to bring together. So they're all some kind living the dream that Imagine has the opportunity to change the world, and that creates a huge motivation for them to get this done and quickly done.
Do you think the regulator's ready to have that conversation?
I think the regulator is ready, yes. I have seen this in many discussions with them, and they are ready, I think, even to speak about that it's maybe not a reactor regulation for the zero power experiment. It's more like another nuclear installation. So when you think about criticality safety, for example, or decommissioning, and when we are there, we can think about what is called a critical experiment, and that will give us some design rules what we have to deliver, that we are on the safe side, that there is no risk for the public, and that should make it a bit easier.
So I guess you'd describe yourself as a visionary. Is that right, Bruno? Is that accurate?
Yes, I would say like that. I'm thinking about the future of nuclear, and that's the aim of it. not to be bound by the limited thinking, this is the reactor we have, to what could be the perfect solution that nuclear can deliver a clear and significant contribution to the net zero society of the future.
Yeah, interesting. Yeah. So let me ask you another question. If you were given everything that you ever wanted, and the zero power reactor project works well, and so does Imagine, and everything that you want to happen with respect to this project happens in the UK, what does the end game of that look like for people? What's your ultimate vision of how many Imagine type reactors that we have in the country? What are they doing? Where are they? How would the landscape change if you got everything you wanted?
I think the biggest change for the public would be that we have resource security. So we would have resources for a very long time of electricity production. We've made this calculation about 7,500 years of electricity production for the UK. Resources are available in the country. So it would create us independence. Independence where we can then say, we decided on an investment and we can pre-calculate how expensive the game will be, since the resources are there. So we don't have any risk and any dependence anymore on resources. And in addition, we would relax the waste problem. So that is the opportunity given. And when we take this together, then we see that it has the potential to change our electricity supply, and how many reactors you want to build would at the end be a question of demand. It's, if we say we have a robust renewable energy system, which has to be backed by maybe 50% of technology where we can control the power production and control it up and down, then we can go for the 50%. It doesn't mean that we should not use renewable energies. I think we should find a good balance of different energy production schemes to back up each other.
Sure. Do you see, does that mean we're going to be opening up new nuclear sites to host sort of Imagine technology-based reactors? Is that how you would see it? Because we're using up our existing nuclear sites quite quickly with our current plans, aren't we?
Would we open up new sites? I don't know if we would have to open up new sites. It's always a question of demand and delivery. There are several nuclear sites which are not limited in size, I think. So who tells, for example, that in Hinkley Point C you would not have space for another reactor? So maybe it's better to go the way to use the sites which are existing, since instead of trying to open new sites. But that's at the end a matter of the demand. When we know how many reactors we want to have, then we should go into this discussion. But the first step would be definitely stay on sites which are existing and show the opportunity to the public.
Thank you very much, Bruno.
That was really interesting. Okay, bye.